Hello and good morning. Let's take a look here. On number one, you have 0.435 liters is equal to x cubic centimeters. And I had to go online to get this conversion right here. So here I have liters at the top, so it's going to be 0.001 liters over 1 cubic centimeter. And there it is. That's set up as a proportion, and that's the way I want you to do your work. So it's going to be 1 times that, which is 0.435, and then x times that, which is like that. Now you got to divide. You take your calculator, and you can verify that this is the correct conversion. You can go online. So here, I'm going to start it up, clear it. I'm going to take 0.435, divide it by 0.001. When I do that, I get 435. 435 cubic centimeters would be the answer. For number two, let's take a look. This one right here is Kim hit Dave before Dave caught me. This is milliliters, that would be this one, okay? And meters is a base. And actually these units are not the same. So this should be the same. So we'll make this one liters. So change that. Okay, anyhow, to work this one, you're at liters, which is a base. And you're going here. So you're going to go 1, 2, 3 places to the right. 1, 2, 3. So you're going to add 2 zeros, and you're done. All right, let's move on. Copy down these notes. We're going into 7.2, and we're going to talk about some geometry. Copy everything you see. Okay, so at this point, what does geometry mean? Well, it means earth measure. Point is a dot. There's no such thing as a wide dot or a skinny dot. It's just a point. Okay? You don't have a bigger dot or point. Okay? There's no size, is what I'm trying to say. This one, a line, you can write it two ways. So if this is line AB, you could say line AB, and you got to put arrows on it. Okay? Or you could name it line BA. Doesn't matter. It's still the same line. And a line goes on forever. Okay, a ray, on the other hand, starts at one point and it goes in one direction. So this would be like ray AB. So you would say ray AB. Okay? Now you can't name this backwards. You can't say ray BA. That would be wrong. Okay, you got to start from the end point. Copy that down. Okay, next, a line segment has two endpoints. So a line segment has two endpoints, and it stops. Draw this diagram. Okay, so this one tells us that AB is 10, so put a 10 here. And then it says that BC from here to here is twice that. So 2 times that is 20. So the whole thing, AC, you add this up. And that's called segment addition postulate. Anyway, it's going to be 10 plus 20, which equals 30. All right, next page. Copy this down. Copy all of that down. All right, let's talk about it. A plane is a flat surface. So here's how you draw a plane. Like that. And it goes this direction, it goes that direction, and it doesn't stop. Okay, like the top of your desk is considered to be a plane even though it stops. So it's a flat surface. There's no thickness. You can name this by a fancy letter like a fancy B. You could say plain B. Or you can name it by three non-collinear points. You could say plane A, B, C. Okay? They have to be crooked. Intersecting lines hit at a point. Okay? So 1 point. So if you take a line like that and it intersects at a point. Parallel lines never intersect, like the railroad track. They will never intersect. The distance is the same. An angle is joined by two rays. So if you take this ray and you take this ray and you join them at the end point, you form an angle. Okay, A, B, C. This is called the vertex right here. It's kind of like your elbow. Put vertex. Now, how do you name it? Three ways you can name it. You can go this way, angle ABC. You can go backwards and say CBA. Or you can name it by the vertex, angle B. 3 ways to name an angle. Okay, we already talked about the vertex. This upside down T means perpendicular. So that means this line and that line hit at 90 degrees. They are perpendicular. Complementary angles means they add up to 90 degrees. So if this angle right here is 30 degrees, then this angle would have to be 60 because it has to add up to 90 degrees. And of course, if it added up to 90, it would look like this. 60 and 30 make 90. And those are complementary. Supplementary means they add up to 180. Superman, it's bigger. Say it to yourself. Superman is the bigger one. Supplementary. So if this angle right here is 20 degrees and they're supplementary, this one would have to be 160 because it has to add up to a line. And every line, called a straight angle, is 180 degrees. Obtuse, acute. Acute is less than 90. So this angle right here is less than 90. So it's called acute. Not because it's good looking. Obtuse is bigger than 90 degrees. So if you have 90 degrees like this, an obtuse angle would be like this. It would be this big angle. So once it's bigger than 90 degrees, it's called obtuse. Sometimes people can be very obtuse. All right, let's keep moving. Copy this one down. Example 2 says find the complement. Well, complement is 90 degrees. So if one of them is 40, 90 minus 40 is 50. So the other one has to be 50 degrees because it has to add up to 90 degrees. Adjacent angles share a side. So if you look here, this angle, 1, and this angle, 2, share this ray. And since they share a side, they are called adjacent. Okay. Draw this diagram. All right, so ABD. So put your pencil, A, B, D. That's the whole thing. The whole thing is 60 degrees, right here. And then CBD, CBD is this one, number 2. And number 2 is 40 degrees. And they want you to find ABC, which is angle 1. So if the whole thing is 60, and this one is 40, you subtract and get 20 degrees. So angle 1 has to be 20 because 40 plus 20 adds up to 60 degrees. That's called angle addition postulate. Okay, there it is. Here's your work for today. And we'll talk about the different types of angles tomorrow. That's a whole nother lesson. Let's turn our attention now to college algebra. Okay, so it says find the possible zeros. We did the rational zero theorem yesterday, and it's PQ, so it's P over Q. But remember, P is this one, and Q is this one. Okay, it's backwards to me. So you take 64 and break it up. So 1 times 64, 2 times 32, 3 doesn't work, 4 does work, or maybe it doesn't. Let me check. So 64 divided by 4, it does work. So 4 times 16, okay. 5 doesn't work. I don't think 6 works. I think 8 times 8 is 64, and there may be more, so check them, but I'm going to go with this, okay? Now, this is a positive, okay? So we want it to be a negative. So I think we got to do plus or minus on all of these, because one could be a plus, one could be a minus. Anyway, it says do synthetic division on the first two. This is the 6th degree. So you got to go 1, and then you're going to have 5, 4, 3, 2, 1, and then 0 would be negative 64. So write that down, and then I want you to do synthetic division on 1. Remember the process. Bring it down, multiply. Bring it down, multiply. Bring it down, multiply. Bring it down, multiply. And you just keep doing this. Okay? And then 1 times 1 is 1, so you're going to get a negative 63. And this one right here is not a 0 because it doesn't end in a 0. All right, today you have a worksheet, and the worksheet looks like this. So for the top part, they just want you to find all the possible zeros using P over Q. Now look, if you're at home, you can copy it down. If you come to class and you're looking for a worksheet, hopefully they're either in the folder or on my table. If they're not, then guess what? You can go back to the video and copy it down. Okay? The second part here, it says find all the possible zeros, and then they want you to do synthetic division. All right, have a good morning.